Great, yeah. So yeah, I'm Conor Flanagan. I work at Arm. I joined, well, I'll get into that, but I went to York, University of York, 2013 to 2017. I took, so that was 4 years, but my third year was a placement year where I went to Reading, Maidenhead, just down the road from here actually, for a company called Socionext. And there I was kind of doing development kit design, so PCB design, applications, working with the application engineering team. And kind of as that year went on, I really enjoyed it, but I started to realize that actually I wanted to be much lower down in the hardware stack. So still hardware, but very low in terms of IP. And so for me, ARM was the main choice. So in 2017, after I graduated, I became a graduate design and verification engineer down in Cambridge. And really, I just wanted to give a bit of context where I was day one of ARM. So really no idea what verification was. I'm sure some of you might be doing some digital electronics at university, but really the only test bench I'd written was basically, does it compile? And this one pattern, the one hard-coded pattern you need for your coursework, does that work? If so, then that's your test bench. It wasn't even called verification. So really didn't know what verification was. Certainly didn't know that verification, that test bench rewriting is kind of one of two halves of simulation and formal verification. So with that context, I was then immediately put onto our rotation scheme, where the first rotation I was doing, which is 3 rotations of 4 months. The first one was investigating the use of formal verification on clock domain crossing problems, so CDC. You might have heard a few of the tool vendors talking about CDC before. Essentially boils down to a problem like that, where you have some data moving across clock domains, so blocks on 2 different clocks, and don't need to know too many details other than that you need some additional hardware in here to make sure that you don't lose any data. And essentially there was a new formal tool out to try and solve some of these problems, and my job as a graduate was essentially try turning the tool on, see if we can find some bugs. But yeah, really had no knowledge of formal and no knowledge of clock domain crossing or that microarchitecture. So it was a fantastic first rotation really in kind of the breadth of what verification is. It didn't touch a test bench. And yeah, I got to know formal so much so that I actually really enjoyed it. And I decided that my second rotation would be to kind of zoom out a little bit and join a methodology team at ARM, who were not just looking at CPUs. We decided, GPUs and system levels, they're all using formal. Why don't we jump out, create a little team that's kind of going to consolidate a lot of the scripts? So we were kind of having a lot more conversations with other teams saying, how are you using formal? What problems do you have? Can we solve the same problems? So I got to learn some scripting languages, Python and Tickle, but kind of mainly it was more soft skills. And that was my first indication that actually verification it's a full-time job, and you need specific skills to be a verification engineer. You not only need to know the technical stuff, but you need to be able to talk to people, which sounds simple, but obviously people are complicated. And yeah, I'm not sure if you're spotting a theme, but I really like formal. So my third rotation, I decided to go out and join the architecture team. And this really was like an eye-opener in terms of how broad verification is and as an industry. So this team introduced this idea that actually what I'd been doing before was verification, which they would call checking the behavior of a design against a spec. That's verification. So does your design actually do what it should do? And if it doesn't, there's a bug in the design, that's great. But actually they were introducing this concept of validation, which was, what if the intent of the spec is wrong? So you're not just checking design against spec, you're saying, right, well, the spec is different. So we had to come up with some fantastic new new properties and new assertions to check. That was kind of eye-opening. So just a brief run on formal is simulation, you'd be mimicking events of real life, and then every cycle you're just checking, is anything broken? But you have to handwrite the stimulus. Formal kind of flips that on its head and says, well, here's all the behaviors of your design and assertion. Just give it to the tool, give the design to the tool, and let it solve it like a simultaneous equation. So you're essentially saying, prove to me that the behavior holds, or show me that the behavior will not hold, and therefore that's a bug I can fix. So what we did with validation is we essentially said, well, there's some parts of the ARM architecture that say if this architectural feature, let's say memory tagging, let's say that's turned off, then the spec says the system register state is unchanged, or it's unused in the architecture, which basically means we can have a check which says if we turn the feature off, and then we tell the formal tool toggle those system register pins, we assert that the architectural state is then unchanged. So what we're actually doing there is trying to find a bug in the spec, because if we find some architecture state that can be changed, that means that that line of English in the spec is wrong, that it actually isn't invisible. And therefore, you're finding a bug in some English text. So it's really strange concept, but it was fantastic eye-opener in terms of, well, formal verification and validation go all the way out to architecture. So we're not finding RTL bugs, we're finding literally bugs in a PDF document, which is kind of really pretty cool. And yeah, learning more about the architecture in terms of memory models and things like that. So what I would say the big advantage of ARM is in terms of verification, in my experience anyway, after that year of formal, it might be logical to then become a formal engineer, but actually ARM decided that I was best placed to go and join a simulation team. So with now no knowledge of how a big test bench team works, I was given, well, I was put onto a bigger team there, which I would say there's probably 15 of us on one test bench, and that was one unit of a 4 or 5 unit design. So it was kind of mind-blowing that that was basically like a software team, but we were all verification engineers, all running on one test bench. I think you guys, some of you guys were in the UVM talk before, and you could see this, how that scales so quickly is, yeah, that it blew my mind kind of how complicated the test bench was compared to the framework you might write in university. So as well as the system Verilog and Python that I picked up from the rotation, I had to learn some C++, because some of the checkers that I've done there, we decided to not use UVM, we would use in C++. That's another software language to learn that kind of design would never show you. A new microarchitecture. So this time I was actually verifying a CPU. So we're finally on to what ARM actually do, which is CPUs, and actually now verifying a CPU. But kind of speaking to designers, understanding what they think is a concern, what we're verifying. And the main difference was that all the rotations up to that point had been solo research or in a very small team with maybe one lead on the rotation. And suddenly now I was in a team of 15, and the processor takes 90 people. You kind of have to get used to how those bigger team works. So another thing to learn, all within the space of a year. A couple of years into that, so I've been at ARM now for 4 or 5 years, we realized there was a little gap in some of the test benches where we weren't really checking this architectural feature. I won't go into too much detail. It's called RAS, or reliability, availability, serviceability. It's essentially a way for hardware to report some errors. That's all we need to know. But essentially, we had some stimulus holes where the test benches across multiple projects weren't able to inject these errors. So I was given a couple of graduates, which was fantastic, really get them on their graduate rotation. And we essentially wrote a small bit of verification IP, which is VIP, which is what you've heard a few people talk about already. We decided to write some internal verification IP to essentially verify this extension of the architecture. So then, of course, comes along with that, so soft skills of leadership and management. Never, ever touched things like that before. So that was fantastic to learn that stuff. Really kind of good sense of accomplishment with that team, because we really did add value, despite only being 2 years into the company, or 3 years in. I really learned about cross-site working. So if you can try and imagine a 3-year-old ARM employee and 2 graduates on a call to the Americans and the French teams and on the ARM offices, trying to convince them that they should use this verification IP because it's found bugs in Cambridge projects. That was kind of a real eye-opener in how to manage soft skills and how the role of a verification engineer is not just technical, it's soft skills, it's a lot of sales. We really had to sell the VIP, even though it was internal. We're saying, like, if you use this, you can help develop it with us. It'll increase the quality, a lot more people will be on board. So we've got to learn how to do that, and ultimately got to learn about reliability, availability, and serviceability, which is just another chunk of the ARM architecture. So yeah, in summary, really, there's 3 points here that kind of verification, or what 4 or 5 years of verification has taught me. But essentially, as an early career choice, it really has shown me that there's a lot of engineering aspects of engineering in the role of a verification engineer that I didn't even know existed at university. Things like I was talking about, the leadership and the management, time management, communication is huge. So a lot of people, then maybe the predisposed thoughts of a verification engineer is kind of huddle over their desk just checking someone else's work, and actually it's hugely proactive. It's very team driven. All elements that actually specifically I think a verification engineer needs. Skills that I also think are very common at university. You know, your group projects, time management, communication are all big things at university, and a lot of people miss them on their CV. And they're actually very key skills to specifically being a verification engineer. So always consider adding them on your CV, because if you can write the best UVM test specs in the world, but if you aren't speaking to designers and hearing what they have to say, then you're not really going to get anywhere. Second point I would say is that, well, yeah, can't really not touch on the technical skills that you learn. I would say as a designer, you get to know System Verilog very well, and you get to learn the architecture well. But you maybe draw a lot of diagrams to understand what you're doing, but you wouldn't really touch C++ or Python. Verification engineers, I think we've speaking to some of the graphical guys before, and like we're all touching Python, C++, System Verilog every day. We're talking 3 languages across a day, every day. Another fantastic thing to have on your CV, being expert in multiple languages for future roles or whatever you wanted to do. I must stress as well, these are things that I didn't have out of uni, so you can learn them on the job as a verification engineer, which is nice to have. Actually, yeah, the Dualos guys that were in here before, so they offer the System Verilog UVM. So through ARM, we were put on a lot of the courses. So I've been on the System Verilog, the full one, not the 1-day one, the 5-day one, UVM, Python, C++, really kind of pumping money into the graduates and the verification engineers to show that you really do need these skills, because it's a complex world in verification now. And yeah, finally, my experience at ARM in verification, it's a real sense of accomplishment, and that's kind of not fluffy talk. I really feel like I add value every day that I go to work at ARM. I think ultimately ARM understand verification is a wide field that, I'm talking about validating architecture all the way to verifying a design and sign off. ARM understand that that's a huge range within one field of verification. But ultimately, I think they also value that as a verification engineer, you add value by going and visiting all of those aspects of verification. Understanding that it's a broad field and making sure that people go into all elements is really kind of key to how ARM work at verification. You being an expert in formal isn't helping that much compared to if you knew how formal works, knew how test benches work, know how to close per bridge. All of these things create a much better engineer and verification engineer. Which, yeah, ultimately is why I think verification at ARM is a really good place to kickstart your career, because it builds you as a really well-rounded engineer, makes you think like an engineer, and all of these technical skills kind of set you up perfectly for the rest of your hopefully long career in verification. I think that's all I have. Do you have any questions? Got a couple of minutes. But yeah, no question is too silly, and if you're too scared, then oh yeah.
If I decided I want to work at ARM and then apply in a year's time, what could you tell me to do now?
Fantastic question. So first of all, I'd say it's a great idea. I hope the presentation shows actually that really I came out of university with really not much knowledge on verification. So I would say anything you can do is proactive, will help your interview, will help your CV. Like I was saying, teamwork, having soft skills in System Verilog, some knowledge of C++ and Python. These are all seen, I would say, at ARM as added extras when we hire, because we know that, especially as graduates, you are really open to learning. However, if you can say, I know how to write C++ or Python basic, then that's a fantastic start point. Playing around with what the Dualos guys were talking about, you mentioned EDA Playground. if you can do a Hello World UVM test bench, you are really putting yourself in a fantastic position to kind of be at day one at Arm in a much better position than I was. But ultimately, I would say, yeah, being open-minded is the key. And writing a good CV that shows you're open to learning and you have those soft skills is higher priority, I would say.
Thanks, Conor.
Thanks very much, guys.